Hi everyone, welcome back. In the last video, I have explained to you what is the support vector machine and how to build that model and train, test, and visualize the results. And in this video, I will continue with decision tree. So, what is a decision tree? And actually, the decision tree is where we can decide and simplifies their decision making process. So, in the simple statement, I can tell that it is a type of flowchart which helps in decision making process. This simple way, I can tell that it is a type of flowchart or diagram which helps in decision making process. That's it. It is nothing more than that. Okay. So first step will be my extract data. Next step will be my to check what are the null values which comes under the EDA, which is also called explanatory explanatory data analysis. To where I will check the whether it contains null values or not, and what is the type of the data it contains, and everything about the data frame. Next, feature extraction. After the feature extraction, I will build a model building for the decision tree. Next, I will evaluate the model evaluation. In the sixth step, visualize the graph. Okay, so these are the steps that to be followed for the decision tree. So what are the steps? Once again, extract data. After extracting data, I will check whether null values are or not in the EDA. If the column contains integer or float or object, and in the feature extraction, I will take out the train test split for 30% of data for the testing and 70% of the data for training. And in the model, I will fit that training set. And after model fitting, I will check the model is trained proper not by using the evaluation metrics using MEA, mean absolute error, squared error, R2 score, test score, and training score. After that, I will visualize the tree map and decision making graph. I will make the graph for decision tree. That's it. These are the steps to be taken. So in the next video, I will implement those steps. Stay tuned. Thank you. Hi everyone, welcome back. In the last video, I have explained what are the steps required for a decision tree. And decision tree, as we know, that it is a type of the flowchart or diagram which helps in the decision making process. If the word comes decision making process, which algorithm is used, then we can directly say the decision tree. And by the way, it is also used for in it is also used in both regression and classification. Okay, this is just similar to the SVM. So SVM and decision tree also used in both regression and classification. So first step is my extract data. For extracting data, I have to import the pandas package as pd data is equals to pd dot read csv file. I have already copied the path. I will paste it here. Data dot head will give first 5 rows. Let's check what it will be. What are the values? Slash backslash. Make sure that before running you have to give double slash or single opposite slash. So these are the same data frame. So I'm having the position analyst levels and salary. Object is my position. So in the data analysis, I will check whether it contains null values or not using data dot is null dot sum. If I run this, there are no null values. Data dot info information is object integer. I have to change this object to an integer of float. So before that, let's complete it. Description dot describe. Now in the feature extraction, my initial first step will be to convert this object data type of our position. I will copy this position name. The first I will change it by importing label encoder from sklearn in pre-processing. Import label encoder LE is equals to label encoder data of the column name equals to LE dot fit underscore transform. I will copy this column name, so I am converting it into the integer. Now if I check data dot head, everything is changed. If you see here, before it was object, now it is the integer. For verification, we can data dot information integer is converted into the integer it is converted. Now let's begin with the model building. For the model building, first I have to get feature extraction. For the feature extraction, x is equals to, in the third step only, in the feature extraction I will give data dot ilog include all the rows except the last column. Y is equals to data dot ilog include all the rows only last column. If I execute this and I will print x, position interval got it. If I check print y, I will get this analysis. Okay. Now come into the model building. First I will split the data model sklearn dot pre-processing. Instead of pre-processing model selection, import train test script. and x train comma x test y train comma y test, and these four values comes from the method train test tree, which takes the parameters x and y, where test size I'm giving as 0.3. If I check the dimension or shape, x train shape is x train dot shape. In the same way, for the y train also, I will copy this. I will just change this y. I will change this y. And for the test size also, let's check. For that, I will change this as test, double click and paste it. Double click, just change this to y. Double click, copy, and paste it here. If I run this is what total 10 rows are there. 30% means 3 rows went for the testing, remaining 70% for training, because I have given the test size as 0.3. Now I will to use standard scalar for dimension reduction from scalar dot preprocessing import standard scalar sc is equals to take the reference for this standard scalar. Now I will apply for x train equals to sc dot fit transform x train, and x test also equals to sc dot transform x test. Run this, done. Okay, so now it's time for the model building. Train the model. For training the model, I will import the decision tree from sklearn dot tree import decision tree classifier and regressor. Out of these two, what should I select? I have to select decision tree regressor, because we are talking about a regression. So for the regression, I have to select the decision tree regressor. If I am talking about the classification, then I have to select decision tree classifier. So I will go with the decision tree regressor. Now my model is for decision tree regressor. Now I will fit the model dot fit with x train and y train. If I run this, valid parameters, what will they be? X train and y train. Uh, okay, the parenthesis was missing. No, done. Till now, we have trained the model. Now, our next step will be evaluation. For evaluation from sklearn dot metrics, we will import R2 score, mean absolute error, squared error, and for mathematical calculation, I will import numpy as np. So my test score, I will find the test score. Test sc is equals to model dot score x test y test. For the training score, train sc equals to model dot score x train comma y print. If I print testing score, test score is test SC, and I will print the training score also. Train score is train score. In the same way, I will find R2 score, R2S is equals to. Before that, I will find the product. Okay, it is one because it is a train. The model is accurately one. It should not be one. And y predict equals to model dot predict x test print y predict. This is the predicted values. Now R2 score equals to R2 score. Sorry, R2 score will pass the parameters y test original data into predicted data. In the same way, for mean absolute error also, mean absolute error will pass y test and y predict. For the mean square error will pass y test and y predict. For the root mean square, np dot sqrt I will pass MSC because root mean square is nothing but the square root of the mean square error. Now I print those values. Okay. R2 score is R2S. Print mean absolute error is MAE. Print squared error is MSC. Print RMSC. Root mean square error is RMSC. If I run this, I found these are the values. So it is much more bigger because I used the wrong dataset. If you use the correct dataset, you may get the correct values. That is why it is coming as 1 and the error as 10 to the power of something around 10 into 8. So it should be the error in the selecting the data frame. If we select the correct dataset, it come around 0.2, 0.1. The R2 score will be something around zero point 0.8 or zero point 0.9. So make sure that you have to select the correct dataset. Now it's time for the visualize the tree map or decision tree graph. Now for that, I will import from scale. Let me first make sure that it should be the code scalar dot tree import plot tree. Now plot tree for the model which fits model dot fit x comma y. I am plotting the graph for entire dataset where the feature names which it comes which considered in the list where data dot columns. So what is happening here is I am plotting the graph for the model which fits entire data set x and y and feature names will be the column name which is should be passed as a list. That's why I'm using list. Any clear? Everything clear? So I will plot this plt dot show For that, I will do import matplot lib.py plot as plt. If I run this, I will get the. If you see here, the graph has been done. So it is not clear. It is no clear. So if you want to visualize much more bigger, plt dot figure with size in the list give 10 comma 10 size. If you see here, it is plotted better, something better than earlier. You can drag it out. You can make it as x-axis as 15. Now it is clear. If you see here, it is clear. Okay, this is how you can plot the tree graph. And plt dot plot x comma y. So this is the what it is happening. So if I say scatter, so it is coming as from. I think I have to use model predict. Model dot predict x. I have to use dot ilog because here the dimension of x is 2D because I'm considering the position as well as the experience. Whereas the model dot predict x, it will give only one dimension, which is the salary. That's why I'm using ilog. Consider everything. Only the column. Now, if I see, did you see this? No. If I want to plot that, we will consider everything. We will plot this instead of scatter. Plot. And the color C is equals to red. Done. This is how you can and for this we will give the title twenty dot title decision tree results. Plt dot x label experience or label plt dot y label salary. Run this. Now okay, fine. This is how you can plot, and this is how you can visualize the decision tree. This is the main step that considered in the decision making process. From this, I can visualize what are the how should the decision should be taken. Thank you. If you have any doubts, let me know in the comments. Hi everyone. So today let's begin with the random forest. And a random forest is nothing but the collection of decision trees, which is used for solving complex issues. So, random forest is it is an algorithm that generates a forest of decision trees. Okay, and also it is based on ensemble learning, which means which integrates multiple classifiers pairs to solve a complex issues and increases a model performance. Okay, so this is what the random forest means. And if I in the while implementing the random forest, what are the steps will be considered? So first step is to extract data. Next one is explanatory data analysis. And for third step is to extract the features. Feature extraction. The fourth step, you will have the model building. The fifth step, after building the model, you have to check whether the performance is good or not. For that, model, this comes under model evaluation. The final step, visualize the results. This is the steps for implementing random forest model. So in the next video, I will implement the random forest algorithm and build that model. And stay tuned. We will explain you in the next video. Thank you. So let's begin with the extract data for the random forest. For extracting data, I will import pandas. Import pandas as PD. Data variable which stores the re- data frame read underscore CSV, which takes the file path. Data dot head which displays the first five rows. Before that, make sure you have to give double slash and select the kernel. You have to give the kernel Python exe, then start execute. Once it is executed, you will see the first five rows of this file, position underscore salaries CSV file. So this is the data frame or the data which is inside this CSV file. Now I will check whether it contains null values or not. For that, data dot is null dot sum. If I run this, there are no null values. I will check the information about this data dot info. Now I found this is the data type of each column. Position is object, so I have to convert it into integer or float. For that, I will use the label encoder. Before that, let's complete with the description. Getting the description. Okay. Now for the feature extraction, Before that, I will change the object to integer from scaling dot pre-processing import label encoder. I will take LD variable for a label encoder reference. Now I will convert the data where my position is LD dot fit underscore transform. I will update this same column. I also can use data index ilog all the rows for only the first column. I can use this also instead of position. So it is your choice, whatever you want to use. Data dot head. If I run this, everything is changed. Okay. Now after this, I will split the data. Before that, I have to mention which is independent, which should be the dependent. For that, data dot ilog all the rows is included and except last row. Data dot ilog I will consider all the rows only for the last column. Let's change it to values. Run it. Now execute what is the check the value of the x and y. Print x. Now print y. Done. Now it's time for the model building. So first I have to import from sklearn dot model selection import train test spread, and I will take xtrain xtest y train y underscore test, and these four values comes from which is written by this method x and y train test spread, where I am passing the x and y values with the testing size of 0.3. If I check the shape, xtrain shape is x underscore train dot shape. I will copy this and I will paste again for y train. And I will copy this again for test size. So it is same for everything. Xtest, xtest, ytest, ytest. Run it. That's it. So xtrain and ytrain having the 70% of the data, xtest and ytest with the size of 30% of the data. Now I will use standard scalar from sklearn dot preprocessing import standard scalar. Sc equals to standard scalar. Now I will change the format of xtrain by sc dot fit transform of xtrain. Now I will use x. I will change the x test also. I will update x test also by applying sc dot transform method. X test run. Now it's time. Now it is the time for applying the model. So for the random forest, I will import sklearn dot ensemble. From ensemble import random forest regressor. Sorry, random forest regressor, because I am talking about we are doing the regression model. We are building the regression model. For that I will use regressor, random forest regressor. In case if I am talking or building a model for classification, then random forest classifier. So for now I will use random forest regressor. Now model equals to initialize this random forest regressor, where it takes estimators up to 10 and random state. For now let's start with 0. Anything you can use. Model dot fit x train comma by train. So what is happening is I am applying the random forest regressor with estimators of number of estimations is 10, and with random forest 0 in training the and building the model for and applying the training set for this model. So training done. Now it's time for the evaluation. For the evaluation, I will import from scalar dot metrics import R2 score, mean absolute error, squared error, and import numpy for normal mathematical calculations as np test underscore testing score. I can find the testing score also by model dot score. I will pass I will pass x test comma y test training score train underscore sc variable, which stores the value for model dot score. I will pass x train comma y train. If I print those two, test score is my test sc, and print train score is train.sc. If I run this, I found this is the test score and training score. And you have to give the proper data frame so that the prediction can be done accurately. It should it will be the positive. Next, after this, I will find the R2 score mean square error. R2s equals to, okay. Before this, you have to predict the values. Y pred equals to model dot predict x test print underscore pred. Okay, so this is the 30% of the data has been tested, and this is my predicted values. For this, I will find the R2 score. R2 score for y test, between the y test and y pred. Find the R2 score for raw data and predicted value. MAE equals to mean absolute error y underscore test comma y underscore print. MSC is equals to squared error mean squared error by passing the y test and y product. So here what is happening? I am finding the mean absolute R2 score squared error between the raw data and predicted data. And RMC is nothing but the root mean square error. It can be found by the square root of mean square error np dot square root of mean square error. Let's print those values. Print R2 score is R2S. Print mean absolute error MAE. Print MSC mean squared error. Print RMSC is root mean square error. Done. Okay, so next step will be visualizing the results. For visualizing the results, I will import. Let's change it to the code to cell to code. Import matplotlib dot py plot as plt plt dot plot x. So this is the x value, but you need only the first column. So I will use dot ilog. So earlier I have used dot value. That's why the ilog is not needed. We can use directly against y test or y anything okay. So for now I will use plt dot plot x. I am passing entirely comma model dot predict. I'm predicting whole of comma 1 plt dot show. Now can you apply the give the title plt dot title result visualization. You can give plt dot x label x axis as position. I think it is experience or position. Let's see. Okay, it is x axis is my level. What is my level? Based on the level, you will have the salaries level. PLT dot by level is my salaries. Salaries. Now, if I run this, I will get the result. What is happening? Okay, expected 2D array. I got 1D instead. So what was the issue? plt dot variable executable. If I comment in this, okay, this is the graph. Salary is level. So salary is something 1 e to the power of 6 exponential of 6. So this is how it is increasing in the exponentially. This is the correct way. Okay, that's how you can predict the values. That's it from me. Thank you.